Okay. Update. Disable preview. Alright, what do we got today? Install that. We got that. What to-dos do we have? These three. Pass in, and gamma. Okay, so let's pass these things in. Window dimension. And texture dimension. Okay, so texture dimension, window dimension are being passed in, cons, struct, cons, yeah, C buffer, that's what I called it. Okay, so we've got window dimension and texture dimension up at the top here. So this thing is in the C buffer, which is allocated, and then we write to it. Okay, so texture dimension, well, there's only one place where I'm reading the texture, which is like right here. Right here. So then, D3D11, C buffer, storage, texture dimension is V2 XY axis. Do we have that in here? Width. We don't need to set that anywhere else now. Window dimension, we check that every frame. So D3D11, C buffer, window dimension is V2, window width, window height. Not storage. Okay, so that's being passed in. Let's see if that works. Not quite. Not quite. No errors though. Doesn't quite work. What's wrong with it? Well, let's step through. And see what numbers we're getting. Oh, it's capturing the first 10 frames, that's right. Yeah, we don't need that anymore. Let's go through the vertex buffer. Okay, so do we have the ability to examine 25, 60, 40, and 40? Oh wait, texture. Oh my god. Okay, so that should work. And imagine not having to synchronize them like manually. Window dimensions, we can. Yeah. If only we could have such power of not synchronizing these things manually. It's so good. Okay, well this... Okay, what numbers are we getting? Let's see. Close that, close that. Don't want to save anything. Window dimension is 25, 60, 14, 4 texture dimensions, 32, 32. So this is what we had before. So presumably nothing should be any different to what it was before. Actually, let's I just want to look at the first the first 10, let's say, frames of movement. Well, first let's commit this. Pass in dims in C buffer. Now I want to examine the first 10 frames of movement. Like here. Render to Q for Q capture. Okay, launch, save this capture now. Okay, so this is the first frame that's been captured. This is the second frame. Third frame. Interesting. Fourth frame. Fifth frame. It's like where is all that blending? Are they just like within 10 frames there's no... I mean, I doubt it. That within 10 frames there's no movement. That's weird. I mean, this delta x is very small. And 10 frames when we are running at 165. It's like it's exactly on every time. That's probably wrong. Something's probably wrong there. Yeah. Just don't see that. Yeah, I don't see that being correct. Okay, let's disable the movement. And then do the move. I mean, I guess I'm gonna have to query window dimensions here temporarily. Again, only need the width really. So if window width is that, how do we move it? We know what the half span is, which is that. So window half width is window width divided by 2. Well, 2.0. So we got window half width is however many pixels it is, whereas camera half span on the axis 10. So there are 10 world units per this many pixels. Okay, so add 32 units per pixel is that divided by this. Okay, this should move it 1 pixel over. Oh my god, it's capturing 10 frames again. Note all, note. Can I like, yeah, okay. Launch, capture, close. It is 1 pixel over. Okay, so let's move it half a pixel over. Launch, launch, no. Capture, close. Alright, so it's still here on the edge. Where did my blending go? What happened here? Did I do a change that I didn't realize I did or something? Like, no? So pixel 39 was not show failed events, debug pixel. It's all black. It's all black. Okay. What about the pixel right next to it? Okay, so this one is actually sampling different colors on the left and the right. Yeah. Oh. I'm using TextDim in the pixel shader, and it's not available. That's right. Can I do both? Can you do both? Bind what is it called again? There it is. Bind vertex buffer. So this is no, this is rectangles. Constant buffer. So when we create it, we don't actually say what buffer it belongs to. It's like down here. It's like down here somewhere. VS set constant buffers. I think we're looking at. There it is. Set constant buffers. Well, presumably there is a PS set constant buffers as well. Can we just do both? Like that? There it is. There's my blending. Okay, so we've restored the blending. solid, right? Okay, so I mean, I do keep coming back to this code. Should I just leave it? Maybe. I mean, it's kind of weird and hacky though. I don't know. Let's leave it, but I'll put it to do in here. To do better way to move by pixels. Okay. Yeah, so we can go back to that. Okay. Bind constant buffer to pixel shader. Okay, now we should have two to-dos. There's that. I'm gonna do that right now though. Gamma. Okay, so to do gamma though, I need multiple textures to be able to see problems. I need multiple textures, and so right now we have one, right? Yeah, we have one that's just exported as a PNG. Yes, so that's not gonna work. We're gonna need multiple, and we're gonna need to put them together into an atlas. So let's do that. Well, I guess step one is to have two textures instead of one. And I don't know, like Aseprite. So Aseprite seems like it kind of wants you to have. Where's the? What's this? Add background color. Aseprite seems like it kind of wants you to have one file per animation. View timelines tab. Oh, there it is. There's the layers. Layer 1 is discontinuous. Hundred milliseconds. Cell properties. Z index. You can also log them. I see. Play animation. Yeah, well, there's no animations. Yeah, so presumably, like, this seems like it's a one. I mean, you can have multiple layers, although. What's this? The new layer. Yeah, there it is. What's this? How does this work again? So this is a new layer, okay. Alright. Okay, I can select them. We can presumably add a frame, Alt-N. And is this editing frames or? Yeah, and like when it plays them back, it plays them back like that. Okay. Yeah, let's remove this layer. Can we remove the layer? We can remove the layer, okay. Well, I kind of want to remove this layer too, to be honest. You cannot delete all layers. Well, can you delete everything in this one? Yes, we can. Can we delete the frames? We can. Okay. Let's draw something here. Is this 1 pixel? No. So this is the shape. Okay. This is 1 pixel. Okay. What's the eraser? 2. E and pencil is, no, that's eyedrop. It's B. So E. Oh my god, that is one big eraser, huh? And B. Okay. That'll do. Alright. Pink. It's gonna be pink. E, B. Maybe not pink. There it is. Oh my god. E is erase. Alright. E is yeah, that'll do. Sprite 1. Can we rename this sprite? Save as. Let's call it commando. Well, I mean, that works, right? Alright, and in here, let's just remove this. Okay, that'll do. 1 frame. Okay, maybe make it like, you know, the other way, to the right as the default orientation. That'll do. Very low resolution art, but that's the game. Okay, so we've got some metrics. Well, that's good for debugging. Okay, that does it for this frame. No, we need something else though. We need something else. Okay, so this is the kind of thing you would. Okay. File new. 32 by 32 RGBA, transparent, square pixels. Okay. Okay, so let's save that as whatever. Let's say this is an enemy, Lemurian. What do they look like again? I don't remember quite well, but it doesn't really matter right now. Interestingly, you get the outside metrics, but not the inside metrics. Well, this ends up being 12 pixel. You have to do the math yourself. Looking to the right. Yeah, I don't really remember them exactly. It's something like wow, that is some ET main character right here. Well, I guess that's what they're gonna look like at the moment. It's gonna be an ET main character, and that'll do. Because right now the point is to just have them in a... Okay, no, we don't do that. The point is to have them in an atlas. Commando Lemurian. And does that work? Yes. So we need to load them. And so we're just loading them from PNGs. So, okay, so we kind of want to load all the PNGs in the directory. And at some point, we might want to, well, right now we don't need it, but at some point we might actually want to read actual Aseprite files. Because when it comes to animations and stuff, if you just export the PNG, you know, you don't get where the borders are, so that's kind of not really what you want. You want to know what the frames are and stuff, so, well, right now the PNGs will do. So in this section, we're just gonna go through all the PNGs, textures, well, actually we don't know how many there are. I mean, we can find out. Arena a la carré, arena, texture, PNG count. Type abstract texture. Oh my god, I can't. U32 star pixels. I32, I don't really care. Width, height. Okay. PNG count, well, I mean, I don't necessarily have to do it this way, because reading twice doesn't really... Why read twice if we can just read once? So, like, struct textures. Texture pointer I32. I don't really care. Lang. I mean, okay. Well, yeah. I32 lang, I32 capacity. Texture. Well, capacity is let's say 100, except I called it cap. And then textures pointer is arena alloc array. Arena texture and size is texture's capacity. Don't do that. Yeah, and then here we can just read through them. So find first file. Okay, so we pass in find first file A will do. Data star.png, I think that works. And then find data. Find file data. Wait, what's the type of that thing? My God, this LP stuff. Find data. Handle. First handle. And okay, how does this work again? This API. I don't have the right. God. Why does this open? Okay, find first file. Return value. If the function fails, it's invalid handle value. Cert handle isn't invalid handle value. Okay, find next file takes that find handle and the same data. And what does it return? Non-zero. So do they want me to do a do while? File A, first handle. I guess it's find handle, right? Find handle. Find data. Because the information is contained in that find data. Find data. Okay, so we have two fields that correspond to file name. Well, I mean, we could just examine them in the debugger and see what they mean. That way, does this compile? It compiles. Find data. File attributes creation time, access time, whatever. Okay, see. So alternate file name just doesn't have anything in it. Okay, so file name, this is a file name, but it's not file path. So you can't use it to actually read the file. You have to do some string formatting, which, you know, I would always love me some string formatting. Okay, find handle. No, not handle. Find data. See file name. Okay, there's our file name, which is an LPC string or whatever. W char actually. Well, that's W. I mean, I'm guessing it's just a char star. Char star name. Then we go path. Well, it's stbs p sprint and sn printf. Yeah, so buffer path count. Are we calling it anywhere else? We are. Char star path is arena free footer. Free footer. Well, it's path count free size. Format string is data /%. Yes, I think it's null terminated, right? So path here. And then like arena used plus equals, I mean, well, it's that. Because snprintf will return how much it's used. Is that including the null terminator though? Always returns a 0 terminated string. Yeah, and as the return value, well, I mean, I guess we'll find out what the return value is. In fact, we can find out right now. Let's run up to here. What's arena used? 17984. 985. Okay. So it's actually +1 for the null terminator. Actually, let's make sure that it does what I think it does. Okay, so path is path 0, path 1. Okay, so alright. So it is, yeah. So it will zero it out, but we do need to account for that null terminator like that. Okay, path, then it's %s data :%s name, like that. Yeah, that works. So now we have a path, so presumably we can just read it. just do that. Name, path, pixels. Okay, so this LP file name will be path. Pixels width height. Well, pixels width height, that's what we're storing in the texture. So like texture is pixels. No, honestly, I mean, we just fill it out here, right? Texture. And just down here we go, well, texture.pixels is that, and texture dot width, texture dot height. Well, it's width height like that. So something like this. Okay, this fills out the texture. Now we just do an rpush texture. Like that. Yeah. Okay, so this will fill out this array of textures. Now we need to go through that and build out an atlas. Text index. Well, text index is 0. Is textures capacity text index. Texture is textures text index. What's this? This one width. What are you talking about? Yeah. Yeah, not capacity actually, it's length. Well, okay, so we do need to pack the... Okay, so this can happen down here. So we need to pack the stuff, and then we need to copy each texture over. Actually, come to think of it, well, no, let's keep it this way. There is an STV rectpack, which is kind of for this reason, designed for this reason. New file. Okay. Let's read some of this. More docs to come. Qsort and assert. Okay, let's override that. Well, at least it's one version, not 0 version. Yeah, let's make it all static, why not? Back rects. Context rects, number of rects. Okay, so that's all we need. And it returns an int. Okay, so we need to come up with the rects first. With the rects to back. Which is not these textures actually, because there's a lot of sort of dead space in those textures. And we want each texture to have probably a border, like a transparent border of 1 pixel. Although, do we? Because if each texture has one of those, then we'll have a gap of 2 pixels once they're packed. So no, probably, yeah, alright. So let's not free them just yet, because we're probably gonna iterate multiple times. So this iteration will just come up with the rects where it's the exact outline. No borders, no anything. It's just the exact outline of the texture, no dead space. Although, I mean, we don't need it right away. Let's just put it to do for that. Remove dead space. So let's just assume that we've removed all the dead space and we have the exact textures. Oh well, we have the rectangles. We need the rectangle. What's the definition of this? Well, yeah, but like I kind of need to know what it is. There it is. Reserved for your use. So this is the actual input and this is the actual output. So all it needs is the width and the height. Amazing. Amazing. What's it? tbrp rect. Rects to back. Arena alloc array. Arena strp rect. And then what is it? Textures lang. Rects to pack. Does this compile? Yes. Okay, so that is our rects that we want to pack. Rects to pack. So width and height is all we need. Width is texture width, and height is texture height. Except it's the correct one, right? Text int Okay, so that pretty much fills out the input. STB rectback backrects context, okay. Context rects to back so context rects to back and number of rects is textures length. I don't know where the context is supposed to be coming from, but we'll find out. Assign packed locations to rectangles. Have a was packed flag set to a non-zero value, and x and y store the minimum location on each axis. Top left. So top left, yeah, so we have top left and where they were packed. Okay, well, we kind of expect everything to be packed, so after we do this, we're gonna have to like check that it's been done correctly. STBRP rect is rect to back texture index assert rect was packed. Assert that everything's packed. Okay. Well, last texture index, whatever. Okay, context. Where's the context supposed to be coming from? Okay, so it will sort them. Interesting. STBRP init target. But it also needs the context. Or is the context here like the return value? Pack the rectangle that is width by height and dimensions. Using temporary storage provided by the array nodes, which is number of nodes low. Number of nodes is greater or equal to width. Okay. Number of nodes is greater or equal to width. Setup allow out of memory. After init, so okay. Okay, we don't really need heuristic modification. And that's it. Ah, wait, it returns one if all the rectangles were packed, so we don't actually need to do this. Well, I mean, we need to do this elsewhere, probably. but not here. It's int. Okay, we need the context though. Init target. Okay, well that is that context. Width, height, I mean, I don't know how wide it should be. Width, height, nodes, pointer, nodes, length. Struct. What is this? To be a rect packed node, pointer, nodes, length is 1,000. Nodes length. I mean, we were told to make them the same. You know. Number of nodes is greater or equal to width. Yeah, well, let's do that. And nodes, pointers, arena, alloc, array, arena. That's one of these. Nodes length. Okay. Then we init target. So what's init target? Returns void. Okay. If you do number 2, then the non-quantized algorithm will be used, but the algorithm may run out of temporary storage and be unable to pack some rectangles. Okay, so we did the first thing to guarantee best results. So we still need the context though, so I'm guessing I'm just gonna do that, and then I can just use it. Yeah, something like that. Okay. Okay, so assert that everything's been packed. I mean, I guess everything, all rects packed. Okay, so now this array has all the information we need. About where the rectangles are. Oh, it should be. Which is top left. We already have a width and a height. And now we have a top left and whether they were packed. Alright. Anything in the context? Okay, let's just not do any of this for now to make it compile. Unused function. Oh my god. Pragma. Was it like diagnostic ignored or something? W. No. Is W unused function? Is that how you do it? Yeah. Also, while we're here, is there a way to make sprintf and all the other stuff static? Yeah, there is. An image. If not defined, def. Yeah. Yeah, okay. Okay, I don't really know if any of this will work. Okay, well, we've ran up to here. Not that many locals, that's good. Okay, we've got what? Textures. There are 2 textures, which is what you'd expect. 25 pointer not found. Okay, alright. Rects to pack. Oh my god. Rects to pack. I mean, we have them here, right? That's the first one. So we've set the width and the height. There is your nodes. Actually, how much are we gonna use on the arena with that? Size is... let's do... 16k. I mean, whatever. We have 16k. Why not? Nodes, context. Okay, let's see what that's gonna do. Set the next. Context. Boom, boom, boom. Width, height. Sell out of memory 0. Alright, then it calls back rect. All rect back. Yeah. Rect. Zero. Okay, so the first one is apparently at... oh yeah, that's why there is an ID. Because they get reordered. That's right. Rects get reordered when packing, so use ID to ID them. Was packed. That second rect, that one's at 0, 0. Yeah, so we have 2 rects of the same size, obviously they're just gonna be next to each other. Alright. Well, So we have a texture array. There. Okay. So this is the init, this is the backing, and this is the usage of what rectback returned to fill out the atlas. Of course, we should actually have the atlas first. Well, first we need to work out what the atlas dimensions even are. Because like here we can, like we don't have to give it a height of 1,000, we can just give it a height of like whatever, you know. Is this an int? Yeah, it's int. Just give it a height of int max. You can make it however high you want. The width, 496 should be enough, you know. Okay, now we need to work out actual atlas dimensions. Texture atlas. Assert that rect was packed, and then atlas width is going to be max atlas width rect x plus rect width. And atlas height is similarly max rect y plus rect height. Okay, so this should give us the atlas dimensions. Then we do atlas pixels is arena alloc array. And we don't actually need this to persist, right? Because we're just going to be sending that straight to the GPU. Atlas pixels is arena like arena u32 atlas width times atlas height. Okay, now we have an atlas. Now iterate through this again. This time we're going to be freeing them at the end of that. Okay, so this is the rect. Textures, right? Texture is textures pointer plus rect ID. There. Okay, so we have both the rect and the texture. Okay. We have both the rect and the texture. Yeah, so this is like the original textures that we loaded. We are gonna have to remove that space though, so that's gonna be a separate step. Well, really we just need to do a copy now, right? We need to copy from the texture into the atlas. So for each row, texture row is 0, texture row is less than texture height, text row so for each row we need that pointer. So the source is texture pixels plus text row times texture width. Destination. Okay, so that's interesting. So the destination, it is atlas pointer, except that, so atlas pointer is the top left. So we need, wherever we are starting from, we are going to have to add text row times atlas width. Well, no, atlas dot width. So this would go to the right row in the atlas. But we also need to offset that by rect y. So this is essentially text row plus rect y. Times width, so that's the row. And also horizontally, it's rectx. Yeah. So this is pixels. And do a mem copy. Destination, source, and size. Size is texture width. Times size of U32 that. Yeah, because rectx plus rect y times atlas width, that's the top left of the texture. Yeah. So row by row we copy them. Copy them over. And then we free. Okay, well let's see what that's doing. Rects to pack, yeah, we can get through that. Text row 0, rect, ID 0, was packed 1. x32, y0. Okay, so text row is 1, apparently. Okay, skip that first iteration. So pixels plus text row times texture width. It's right there. It's right there. Like just like rect ID. Like, can you not do this? Oh, for fuck's sake, you piece of shit. Oh my god. Is Visual Studio gonna do any better here, I wonder? I don't have high hopes. But maybe. Locals. Oh look, Visual Studio lets me examine variables. Well, that's something. Yeah, source dest, memcopy, okay. Free the image. Okay, so now we just need to set up the atlas as the one texture that we are using. So width, height. Width becomes atlas width, height becomes atlas height. Pixels is atlas pixels, atlas width, oh yeah, atlas dot w, and atlas dot h. Okay, so that successfully compiles. What's atlas? Like 64 by 32. Actually, that is correct. Yeah. What's this? Alright, well, there's our two textures. Packed correctly. Okay, it'd be nice to remove that space though between them. Okay, well, basically what that would entail is creating a separate set of textures. We don't need capacity here. No dead space. Or trimmed or something. Textures trimmed. Textures trimmed. Oh, there's text trimmed, I guess. Pointer is... Well, actually, we don't even need that. We can just have this be a pointer, right? Arena, alloc, array, arena, texture. texture and textures length. Well, I mean, textures trimmed. Fine. Let's do an iteration over all these. Let's be consistent here, I guess. So there's the text, that's the normal texture, that's not trimmed. Row, column. Pixel is texture, pixels. Row times texture width plus column. Okay, so if pixel, then what? Well, we kind of need to detect the top left corner that we can start from, which means detecting the minimum. Oh, okay, so let's start with the left edge, right? So I32 left. Set it to texture height. If pixels left is min, left texture, left column. No, wait, texture width. Left init to texture width, right. Will frames in an animation eventually be the textures? Well, yes. They will be in the atlas. Okay, right. 0. Right is max. Top. Bottom. Okay, top is min. Top and row. And bottom is max. So in that case, you will need a consistent coordinate system. Yeah, we'll think about that when we actually do animations. Right now, we don't need any wasted space. Well, presumably I want a pointer to the trimmed. Okay, trimmed width, height, and pixels. Well, pixels would be texture pixels plus top times texture width plus left trimmed width is right minus left is bottom minus top. Alright, so well, can we set a breakpoint here? No. Okay. Does this let me examine trimmed? Why not? Why is it not found? What? Just debuggers. Like, can they just work? Like, no. No. Trimmed. So see, Visual Studio can do it. Of course, it can only do it like a little bit. Watch one. Can we remove that? Trimmed at 2. Is that possible? Yes. Alright, here we go. Let's just look at the result of this. Yeah, that doesn't seem right at all. What happened there? Shift F. If it could just not move around quite so much. 13. Okay, so this is the first texture, right? I mean, we can just check all this stuff pretty easily. 13 left, yeah. Top 20, which is that. Right is 13. Okay, so this is 32. So that means this is 22. So this is like 31. This is 21. Yeah. Bottom is like right at the top. 31. 31. Okay, right, left, trim. Okay. What happened here? Did it? Okay. Okay, what about the next one? Left 32. Wait, hold on. Let's run through that. Yeah. Does this not do what I think it does? This the dash 2? Do I have to do it this way instead? Or what? No? No, that's also not possible, apparently. Value. Okay, fine. Texture trimmed. Oh yeah, it's texture trimmed. Can I look at the value? Can not allowed to look at the value. What about like that? Not allowed. I'm not allowed. Okay. What? I mean, we're gonna use these trim textures somewhere. Might as well look at them there. So this is the trim textures. This is the packed. Okay, so we're packing trim textures, not actual textures. That's the packing. We know that works. Yeah, we know that also works. Yeah, so right here we need all three. Textures trimmed plus rect ID. Because we trimmed them before the packing, so they're in the same order. Yeah. So where is the trimmed? Okay, source is not texture pixels, it's trimmed. And it's not texture row, and it's not texture width. All of this is trimmed. Yeah, we only need the texture really for freeing it. That compile. That compiles. Okay, what are we gonna see here? Well, let's go to the end, like here. Okay, so I'm not allowed to know what this is. Debuggers won't let me. Okay, well, it's clearly wrong. Because, oh, yeah, right. Because the pitch of the texture is actually texture width. But we're copying the trimmed width. Yeah. So something like that. It seems like we're cutting off things here. Yeah. Because, well, I think it's a +1 situation, because if it's like, if left is 1 and right is 3, then it's 1, 2, 3. So it's 3 minus 1 plus 1. Yeah. Same here. No, not that. Yeah, so this seems to be exactly packed. The tops are the same. Yeah. Let's just create a new layer and just like draw an outline. Hold on. So like I expect this to be top left, top right. So it's like that. Yeah. Okay. Well, let's just delete that. Alright. Yeah, something about having a typedef inside the function that it just doesn't like. I wonder if that's it. What if I just move it out? Will it let me examine variables then? Where's my trimmed stuff that I was trying to examine here? So now I'm allowed. I see. But why would it matter if the typedef is inside or outside the function? Why would it matter for a debugger? Like, you can see what data is. Okay. Okay, well, focus on the primary sidebar. Run use diagnostic, static, SGBs, that is the texture. Read in all the files. I'm not closing the files. Should probably close the files. Close handle H file. Okay, does that work? Works. I don't want to quit. Did I alt tab? Yeah. Wait, what happened here? Did I like... So what's happening here? That's it? That's all the changes? That's it. Rect back, well, that's just, the whole thing is new. New files here, that's fine, and those are binaries. Back multiple textures. Yeah, back multiple, that's fine. Okay, so the whole point was to actually do gamma. Well, I think there is an example What's that article called again? Like Gamma Correction Games. Let's see if we can find it this way. Everything you should know. Manual. Okay, is this it? Oh, that's one of them. Of course, this is like 3D stuff, but there are some examples I remember reading. More results. This seems like what. Yeah, there it is. So in 2D, top gradient, okay, well, yes, we're doing some of that. Okay, so we can probably... Okay, so we are going to be doing alpha blending, so this sort of thing. And the top one is drawn with 100% of it, the bottom one is 50%. The left image is correct. This is... Okay, so it's darker. When you do gamma incorrect blending, it's darker than it should be. Okay, so can we just... can we replicate that? Like, what's the minimums? Like, we can have just a green line and a yellow line and like one green line and one like red line. So it's... Yeah, this is fairly obvious, the difference here. So let's do that. Okay, so first of all, what happens if I create a new layer and put something in it, right? And then make that invisible. Will they be composited together or not? Save. No. So it respects invisibility. Good to know. Alright, well done. What is it? E to erase. We want one green line, that's vertical. Fully green, please. I want it to be fully green. Like that. Yeah, just make it a square. Can you draw? No, wait, this is an eraser. There. Okay, we have a green line. Now, new layer. Can we make that invisible? And what? We want a red line that's horizontal, and alright, so let's just do that. Fully opaque and 50%. That's green. Okay, I want it to be fully red now. Oh my god, what? Why did that happen? What? Spray? No? No. No, what the fuck? Can turn off the spray. No spray. Why? I mean, it's good to know that it has that feature, I suppose. But like, how do I make it not happen? Is that... that's a spray tool as opposed to a pencil tool. Shift B. Oh, did I press Shift B instead of just B? Okay, well, whatever. Why are we back to... oh, wait, this is green, this is red. This is meant to be red. And then 50% opacity, so... well, 50% is 127... like that. Close enough. Alright, so now we just need to kind of overlay them on top of each other. So let's make the background actually black so that it doesn't interfere with this. Okay, the background is now black. And we have two rects. One is in the top left though. And also in this half pixel space. Well, I mean, I could just do 0 or something. Okay, now if we could just move it down, that first one, move it down by per pixel times like 50 or something. That would move it up, right? Well, yeah, I think we're moving it up here. Minus 3. Okay, well, I mean, we're moving the wrong one over. Let's do it this way. Ah, there it is. Okay, so can we actually see what the color is supposed to be, like in RenderDoc, let's say? Launch, no. Capture, close. Okay, there it is. Okay, so I think this is where we see the colors. Like this is 1. Yeah, so the last one's alpha. Well, in this case, alpha doesn't really do much for us. So this is 1. This is 1. Okay, so yeah. So it blended 1 in the green channel to like 0.5 and 1 in the red channel to 0.5. Can I like see? Well, first of all, let's actually see what the inputs there were. Okay, so the texture that we sampled is all green. Yeah, all this blending doesn't really do anything in this case. So blended we are all green. Input color is all 1s. So the result is just green, fully green. And then on the GPU it would have done the blending. of course it would have done that twice. So that was the first pixel which is debugged, where it was green. So the second one, so this is all red. Then go here, blended. Blended, we're all red. Well, all red with half alpha. So result is just all red with half alpha. And that's what's being blended with the green. Yeah. Where is my render doc? There it is. Okay, I guess we kinda need a way to check what this color is like on screen. Do I have color cop? No? No, did I remove it? Oh yeah, I remove restore. Maybe I should just pin it. What a useful utility, right? Alright, okay, how do you do this again? Like that? Okay, this is gamma incorrect. And we are at 140, 117, 17 apparently. Where did the blue come from? Oh, because this isn't green. Well. Okay, what's this? That's that. Right. 140, 117, 117. Well, I mean, let's replicate the colors first. This was 24, 234, 34. Now that's a nice sprite actually. Okay, so this needs to be not that, but 24 to 34, 34. Now 255 alpha. 24 to 34, 34. So that's the color. That's the green, right? What's the red? The red is full red, okay. And this is full red with 50% transparency. Okay. So now we do the blend. Okay, I guess we can just close that, save. Compile. Render doc. Which is this. Render doc. We don't need this debugging. Okay, launch. Capture. Did it capture? Yeah, there we go. Captured frame 686. Okay. let's look at the colors. Okay, so this is 255, and this is with half transparency. 24 to 34, 34, which is correct. Actually, we kind of need that. Okay. Right, there it is. 255, 255. Yeah. 24 to 34, 34, 24 to 34, 34. Okay, so what's this? 140, 117, 17. What's this? 139, 117, 17. Okay, so we do have that alpha gamma incorrect blending. Pretty much exactly, almost. And correct blending would be 189, 171, 22. So like completely different. Yeah. Yeah. Okay. Where? Okay, so there are some places where we're mentioning gamma in the setup. So one of them is this one. So this is the output format. One of them is texture format, which is here. Yeah, and actually speaking of texture format, so we're saying that the textures are that, so there is no sRGB specifier here or anything. So is it messing with the textures, or is it just giving us the textures as they are? I guess we can see that here. So this is supposed to be, well, I mean, if we just go into one of those. What are we sampling? We're sampling those values. Okay, these values. And what are they supposed to be again? Like, what are we specifying them as? A sprite. So this is the 24 to 34, 34. Okay, so this seems correct actually. Like, see, 24 to 34, 34 divided by 255. Yeah, so no, we are getting the correct texture. So I think texture format and whatever else is doing what it's supposed to be doing. It's not converting anything unexpectedly. What about alpha? Like when we define the blender here, do we say anything? Do we say anything about blend source, blend inverse source, add? Blend source, blend inverse source, add. And then write all. Blend enable, source dest, blend ops, and then write mask. And I think this is just, yeah, this is specifying the math operation that we're supposed to be doing. Okay, so if we change the texture format, actually let's verify that. Like if we change the texture format, will it like change the color that comes out? Because presumably that's what it should do. I mean, maybe. Let's go to RenderDoc. Where is RenderDoc? Say sprite. This is RenderDoc. Okay, so these numbers are different, I'm pretty sure. History, debug pixel, copy. Okay, so this is what we got now. So this is what we had before. It's what we specified. And now it's different numbers. So yeah, more of the texture, somewhat, which is definitely not what we want. Okay, so we don't want to be changing that. Syntax highlighting just broke. So the other place with sRGB, I'm not even sure we can set sRGB here actually. Whatever it is. Let's run the target. unorm. Yeah, there it is. Yeah, I don't think this will work very well. Yeah. Only support the following for, yeah, this is not even a supported format. It's, oh my god. There. Okay. So the idea with Gamma is that the stuff that comes in is in sRGB space. And actually, do we want to morph the texture? Hold on. What were the colors again? So the sampled colors copy. Are those. Okay. So these would be the values in sort of sRGB space. And then to convert them to linear, let's see, sRGB. Okay, so sRGB values, so we've verified that these sRGB values are what we expect them to be. So what do you do when to convert them to linear? I think you square them, right? Like you raise them to the power of gamma. So like squared, you get that. Which is, yes, it is pretty close. I mean, I assume we're using like gamma 2.2 or something here. Yeah, so these seem like the correct numbers except oh, it's probably doing some kind of more advanced, gamma correction than just squaring things. But this 0.82 certainly seems like it's just been squared. It's just the small values that get a different kind of correction. Yeah, okay. So we can get the GPU to essentially do this transform, this first transform into linear space for us. But we can't tell. Okay. So in the shader, oh god, what is the shader? There is the shader. So these colors that come in, they are now in linear space, because the texture sampler will, or the GPU will at some point convert them, which means that we can blend them. So all of this is actually fine. All of this is like gamma correct. But when it goes out, like if you specify the texture to be a certain color here, you kind of expect it to be the same color when it comes out. So we need to do the back transform. And I mean, if the GPU is doing the forward transform for us, presumably it can do the back transform as well. So in this case, we're drawing into a render target, which doesn't support sRGB format. We could draw into a separate texture which does support sRGB format. Okay, well, first of all, let's see if the render target did support sRGB format, would that be all we have to do? Okay, so first of all, let's change this to sRGB. Okay, flip discard. We need to pick something else. Let's read about them. Okay, discard. BitBlit. Sequential. Flip sequential. And flip discard. I mean, I guess we can just try all of them. Okay, let's do flip sequential. Does that work? No. Flip model. So these two don't support sRGB, alright. What are the others? Just sequential. Discard and sequential are legacy swap effects that are predominantly superseded by flip model counterparts. Please consider updating your application. Okay, so that's a warning. Can we like ignore it? No? Yeah, no. We can't ignore it, apparently. The factory did not contain a swap chain. Okay, because yeah, I think I just told it to fade. Is Visual Studio busted now? Is like it's just this is it? This is it? We've had enough debugging. classic Visual Studio W. What? End task. Just end task. Well, at least I didn't get a blue screen. Okay, so let's lower our standards. Temporarily. I mean, I do kinda need to launch Visual Studio though, because Remedy doesn't catch C++ exceptions. devanv.com, yeah. Oh, there is an error. No, wait, they don't support scaling. Ah, so that's an actual error. There's an error there, okay. Do not support scaling none. What do they support then? Do they support something else? Scaling none. What do you mean they don't support scaling none? Can they just not scale? Like why would that be a restriction? Well, let's do scaling stretch. Okay, so we got that warning. Are we running or what? Like I don't get it. No? No. Wait. Is it? Okay, I think the window was created, but it's like fully transparent. Is that what happened? Yeah, I think that's what happened. We have a fully transparent window covering the whole screen right now. Like, see? Why? Why though? Is it because of the format or is it because of the flip model? Well, let's go back to flip discard. Oh, it can't be sRGB. That's right. Hold on. Okay, let's go. Let's do like sequential or something. Let's do sequential, and then let's do unorm here. Okay, we still have this problem where it just doesn't. What? I don't get it. Maybe I should just disable language support. Having to restart the server constantly is kind of annoying. Okay, what if I do discard? Does that do anything? Okay, well, there's definitely that warning, but like, where is the stuff? Where's the window? Okay, so anything other than flip discard just doesn't work. So, all right, I guess we're not going to be testing this after all. We're gonna be sticking to flip discard. We're gonna increase the standards again. Alright, what's in here? So that's sRGB to make the conversion work. This is just the rectangle so we can see the blending. And this is the black background color. Alright, so back to this. Where is color code? Okay, so this is a different color to what it's supposed to be. Because we need to do a back transform. Somehow. And, I mean, given that we don't know exactly how it's transformed, we can't really back transform it in the shader. We kind of want the GPU to just do that. But since we're drawing to the render target, and the render target doesn't support sRGB format, I guess we're gonna have to draw to a texture. Okay, but before we get into that, let's just do, let's go back to unorm for the texture, right? ClangD crashed again. Okay, you know what? Where are the extensions? ClangD. ClangD. Uninstall. Reload required, yeah. There we go. Far superior way to edit code. Okay. So we're back to, presumably we are back to having the correct colors. Let's see, debugging shader, launch, save this caption, no. F12. Where is that group? There, where is color crop? Okay, well, 24th to 34, 34, 24 to 34, 34. Okay, so these are the correct colors. That's the 139, 117, 17, 140, 117, 17. Okay, so this is the gamma incorrect way of blending them. As expected. That's all good. Okay. Now, presumably, if I do a transform here, and then kind of back transform it, and back transform it in the shader, we should get something close to gamma correct blending. Let's just do power of 2 and its square root. Let's go back here, Okay, so 24 to 34, 34, 24 to 34, 34. We didn't mess with this color. That's good. What's this? Okay, so that's still the same. 139, 117, 17. Even though the blend was done in a different Was it? Yeah, it was. 134, 117, 17, whereas it's supposed to be 189, 171, 22. Okay. Yeah. Interesting. Okay, well, let's go into that pixel. Yes. And it doesn't really matter which one of those we go into. Text color top left. Maybe it just doesn't do what I think it's doing. Wait, is this the correct transform? sRGB 0.1 is 0.001 in linear. Okay, well, it reduced the alpha. I mean, yeah, in this case all it did is reduce the alpha. Wait, given... hold on. So we are doing the blend here, right? So we get some blended color. Oh wait, this is a different blend. This is not the blend that I actually want to fix. The blend that I want to fix is the one that I'm not even doing. It's the GPU that's doing it. So I kind of do have to mess around with these. Do I? Well, if I'm not doing the blend, and instead it's the GPU that's doing the blend, then, like, what choice do I have? Oh yeah, now I can't go to definitions. Yeah, you win some, you lose some, I suppose. At least plan D isn't crashing though. Land op. Add, subtract, reverse subtract, min, max. Yeah, this is not really what we are looking for, right? Inf source alpha, inf source 1. Okay, where is the Microsoft extension? .5 stars, yeah, let me just rate it. Let me just rate it. Can I give it 0 stars? No? Extension settings. Let's just do the default here. Error squiggles, I mean... enabled if includes resolve, okay. Inlay hints. Suggest snippets, no. Formatting, disabled. that's not really, that's all formatting. All of this is defaults. Clang tidy enabled, I'm sure. Logging level debug. Okay. Okay, well, we have a lot of errors apparently. Oh yeah, because the IntelliSense mode is busted. Compiler args, compiler path, not synced. Can I just do clang? Does that work? I think it worked. Okay, memcopy is like it's insecure. Is it now? Okay, let's do IntelliSense mode. IntelliSense mode is clang x64. How's that? Okay, well apparently that's a different set of errors that's produced. Like uint64 max is not available. Extra text. What does that mean? What extra text are you talking about? So memcopy is insecure. And uint64 max is not something we're allowed to use. Failed writing. Excuse me? Why would you fail writing those shaders? Now it didn't fail. It only failed the first time. Windows Clang x64. What about Clang x64? Is that different? No? No, that's exactly the same. Linux Clang x64. Oh wait, this is some kind of Clang analyzer thing. Extra text after expected line end number. And where is that? That's an std int. Ah, so all of these numbers are wrong. Somehow. Like it compiles. It compiles, but also doesn't. We also have these memcopy calls being insecure or whatever. No, look at that, look at that. STB image, so many problems. All these command sets. Okay, well first of all, can I just make that go away if I disable Clang tidy? Disable client ID. Does that do anything? No. Okay. Config, fallback config. Okay, well this first one with the UN64 Max, that's a clearly false positive. Like what is that supposed to mean? Disable error squiggles. Quick fix. What's that even mean? Disable error squiggles. Okay. I mean, with this extension we can at least debug things, so that's something. File, what is it? Edit, preferences, keyboard shortcuts. Start, okay, so debug. Actually, is there a F5? Okay, so if we just enable all the F5s, and then launch. Okay, so this is not LLDB anymore. This is gonna be cpp vs debug. Rourke loan.exe. It's in build. Okay, so this should be debuggable. Yeah, it is. And we get the output, so let's see how well this works. I mean, we can already see how well it's working. Not very, clearly. It's interesting though, like is it only the most recent Clang that can like do that or something? Failed writing again. Well, yeah, well that's not gonna be a problem for long though. Actually, what if I do disable error squiggles? Does that do anything? Oh, it does. Oh, it just disables all of them. I see. Does the problem remain, or does it go away? Oh, so the whole problem just goes away. Interesting. What does this do? Clear, disable. Yeah, disable all of that nonsense. That would be good. Okay, so that's how you do it. Okay, that's alright. Okay, well, you know what? Quick fix. Clear this, clear all code analysis problems. What does this do? Well, it doesn't change the settings. And doesn't change the code either. But code analysis problems just go away. Where did they go away? How do you make them come back? Unclear. No, they do come back. Huh. although the value is stored, is used in the closing expression, the value is never actually read. Well, it's because of this, right? It's like, yeah, we know it's not read. Can you disable it for a file? I don't know. Alright. Well, disabling error squiggles means that we can do this. And no, we still have error squiggles. They're just different. There's different sources of error squiggles. It's still there. Okay, now it went away. Right. I see. Alright. Well, I mean, I guess we don't really need Visual Studio now. And, well, as long as this is working at least. Alright. Where was I at on the gamma front? Okay, I got as close as being able to get the GPU to do the correct transform when it reads the texture. I can get it to go from sRGB to linear. But then I want to also convince it to go back. And it's kind of strange that it doesn't just let me do that in the render target. Like, what is up with that? Okay, where is that U norm again? Here. I mean, am I really supposed to like draw to a texture and then draw the texture as two triangles or something? Like that seems like a lot of unnecessary work. What other uses do we have there? Oh, well, there is a back buffer. Discard on present, shader input, unordered access. Okay. Why is it this way? I don't know. Does MSDN have anything on this and sRGB? No. No. GameDev.net. Yeah, well. New version available. Okay. Change the render target view to sRGB. Okay. Oh, so yeah, because we have the render target, but we also have the view, and that was a different. Yeah. But then there is a view as well. Okay, but what's our view? So that's the swap chain, yeah. Is it like RT view? I think we're creating it way over here. Yeah. Okay, so we are creating the render target view here. Except that we are getting it straight from the back buffer, which is obtained from the swap chain. And what we're looking at here is something else. Okay, so there's that get buffer. Create render target view. Okay, what's our description? Null? Ah, there it is. Alright. Okay, so it is a description. Pointer to that. Okay. Ah, so this is the thing that we want to kind of create. Render target view description, and gamedev.net tells us to create a description. Right here. Okay, we don't really have that problem. Okay, so they're telling us to do this. Except that's, I guess, T3, T11 random target view description. Is that a thing that exists? Yes. Format, view dimensions. Is it the same thing? Yes. And then we just pass it. Does that do, well, does that even work? Well, it works. It did something. I mean, this is definitely different looking than it was before. Do we have any errors? No? Okay, well that's always there. Let's see what we're even getting out of this. Okay, well this is definitely different. Let's go back to that. And pin this. Get the color cop out. Okay, what is this color? 86 to 245 102. What on earth? Where did that come from? This does look a lot more like the Gamma Correct version though. Except that this color is different now. So that color didn't change, but this green is just something else. It's completely different to what we expected it to be. Let's go in, debug pixel. What are we sampling out? What are we sampling out? 0.9, alright. What are the numbers again? Terminal. 0.9, 0.09, 0.9, 0.13. And what's this? I don't know why I did Ah, well, this is exactly that. Oh wait, is that because I didn't... hold on. Is the texture not a sRGB? It's not. Okay, well, let's make it a sRGB. Now let's launch RenderDoc. Again. Okay, F12. Alright. Get color cop out. Let's see. 24 to 34, 34. 24 to 34, 34. Then 255. Then 188, 172, 22. 188, 189, 171, 22. Okay, close enough. Okay, I think we got it. I think we have gamma correct blending. And we didn't actually have to do anything in the shader to make that happen. It was all just settings in the in DirectX 11. Interesting. Okay, let's see. What did they actually change? That? Okay, well, this is not related to... okay. And that. Interesting. Well, I mean, let me just link where I got this from. Yeah, we'll keep that. I guess we don't actually have to keep these changes here. Presumably. Something changed the file. Well, let's revert. Discard changes. How does ASprite react to that? Is there a way to like reload the file? No? To do it like this way? Close, reopen. Oh, those are the changes so that somehow stayed. Interesting. Okay. Well, I did gamma. Remove that. Yeah. Gamma correction. Commit sync. Alright, well, that's all for today. Thanks everyone.